Hello everyone. Now we are going to see the subject EC3501 wireless communication. Fifth unit is wireless networking. The second topic in this fifth unit is development of wireless networks. These are the topics in the fifth unit. Second topic is development of wireless networks. Here we are going to see about the first generation, second generation, third generation and fixed network transmission hierarchy. So let's start with the first generation wireless networks. The important features of first generation wireless networks are it is based on analog technology. All cellular systems use FM modulation and all cordless telephones use a single base station to communicate with a single portable terminal. AMPS is example for first generation wireless networks. This diagram indicates the communication signaling between mobile user, base station, MSC in first generation wireless networks. The connection between mobile user and base station, they are called as voice channel and control channel. There are two types of voice channel. One is forward voice channel and second one is the reverse voice channel. Similarly, the control channel is called as setup channel. There are two types of setup channels. One is forward and second one is the reverse. The channel from base station to mobile user is the forward channel and from the mobile user to the base station is the reverse channel. And similarly, in between the base station and MSC, we have voice circuit and data link. This is the block diagram of cellular radio network. So in this case, the region is divided into hexagon shaped cells. In each and every cell, there will be a base station at the center. All the base stations are connected to mobile switching center. And all the mobile switching centers are connected to PSTN, that is Public Switched Telephone Network. In MSC, we have three databases. One is Home Location Register, second one is Visitor Location Register, and third one is the Authentication Register. So this first generation wireless networks provide analog speech and inefficient low rate data transmission. The speech signals are usually digitized using a standard time division multiplex format for transmission between base station and mobile switching center and are always digitized for distribution from MSC to PSTN. The functions of mobile switching centers are it maintains all mobile related information, it controls mobile handoff, and also it performs all network management functions such as call handling, call processing, billing function, then fraud detection within the region or market. These MSCs are interconnected with the PSTN through landline, trunk lines and a tandem switch. MSCs are also connected with other MSCs through a dedicated signaling channel for exchange of location, validation and call signaling information. So this indicates the North American Cellular Network Standard Architecture. It is used to provide user traffic and signaling traffic between the mobile switching centers. So let's see about PSTN. It is a separate network from the SS7 signaling network. Long distance voice traffic is carried on PSTN. Signaling information used to provide call setup and to inform MSCs about a particular user is carried on the SS7 network. The second generation wireless networks. The important features of second generation wireless networks are it employs digital modulation, it employs advanced call processing capabilities, it introduced new network architecture that have reduced the computational burden of the MSC. For example, GSM has introduced the concept of a base station controller which is inserted between several base stations and the MSC. So, in addition to that, the second generation wireless network use digital voice coding and digital modulation. It employs dedicated control channels within the air interface for simultaneously exchanging voice and control information between the subscriber, the base station and MSC. It also provides dedicated voice and signaling trunks between MSCs and between each MSCs and the PSTN. It is specially designed to provide paging and other data services such as fax and high data rate network access. Network controlling structure is more distributed and handoff process is mobile assisted handoff. Mobile units perform more functions than that in first generation subscriber units. The additional functions are received power reporting, adjacent base station scanning, data encoding and encryption. In general, the second generation systems have been designed to reduce the computational and switching burden at the base station or MSC while providing more flexibility in the channel allocation scheme so that systems may be deployed rapidly and in a less coordinated manner. So now let's see the examples of second generation networks. We have Global System for Mobile Communication, that is GSM, and then we have IS-54 and IS-95 standards. They are TDMA and CDMA US digital standards, and second generation cordless telephone, British standard for cordless telephony, Personal Access Communication System, PACS, local loop standard, digital European cordless telephone, DECT. Let's see about the third generation wireless networks. It evolved from mature second generation system, and the aim is to provide a single set of standards that can meet wide range of wireless applications. It provides universal access throughout the world. The distinction between cordless telephone and cellular telephones will disappear. The universal computer will provide access to variety of voice, data and voice communication, video communication services. So the third generation wireless networks use broadband integrated services digital network BISDN to provide access to information digital network BISDN to provide access to information networks such as internet and other public and private databases. It will carry many types of information such as voice, data and video. It operates in varied regions such as dense and sparsely populated regions. It will serve both stationary users and moving users traveling at high speed. The packet radio communication will be used to distribute network control while providing a reliable information transfer. PCS and PCN are used to imply 3G wireless systems for handheld devices. PCS is Personal Communication System and PCN is Personal Communication Network. The Personal Communication System, the other names for PCS include Future Public Land Mobile Telecommunication System for worldwide use, which has more recently called as IMT 2000 or UMTS. IMT is nothing but International Mobile Telecommunication and UMTS is Universal Mobile Telecommunication System. So the examples for third generation wireless networks are CDMA 2000, WCDMA, TDMA, TD-SDMA. These three techniques are deployed in China. Now let's see the fixed network transmission hierarchy. The wireless networks heavily rely on landline connections. For example, MSC connects to PSTN and SS7 network using fiber optic cable, copper cable or microwave links. The base station within the cellular systems are connected to MSC using the microwave link, copper links and optical fiber cables. The several digital signaling DS formats form a transmission hierarchy that allow high data rate digital networks which carry a large number of voice channels to be interconnected throughout the world. The basic data standard digital signaling format in US is DS1. It represents 24 full duplex DS0 voice channels that are time division multiplexed into a 1.544 megabits per second data stream. Related to digital transmission hierarchy is TN designation, which is used to denote transmission line compatibility for a particular DS format. DS1 is used for a T1 trunk, which is popular point-to-point network signaling format used to connect base station to MSC. T1 trunks digitize and distribute the 24 voice channels onto a simple 4-wire full duplex circuit. So in Europe, CEPT has defined a similar digital hierarchy. Level 0 represents duplex 64 kilobits per second voice channel, and level 1 concentrates 30 channels into a 2.048 megabits per second TDM data stream. Most of the world's PTTs have adopted the European hierarchy. So coaxial and optical cable or microwave links are used to transmit data rates in excess of 10 megabits per second. Twisted pair or coaxial cable may be used for slow data rates. For connecting base station to MSC, T1 or DS1 or level 1 links are used. They utilize the common twisted pair wiring. For connecting MSC and central office to PSTN, DS3 and higher rate circuits can be used. So this is taken from the book Wireless Communication by Rappaport. Thank you.